The method we're going to use, though, today is something called substitution and elimination. You guys already know that we can solve systems by graphing. And when we graph, we can have one of three things happen. On the board, we say we can have parallel lines, which have no solutions. We can have intersecting lines, which has one solution. Or we can have lines that coincide, which have an infinite number of solutions. We can still have those three possibilities when we work at algebraic. And I'll show you how that's going to work here in a minute. The first method we're going to look at is something called substitution. So I need you to highlight this for me right here. This is the first method we're going to look at, substitution. Now when you think of that word substitution, substitution basically means we take something out and replace it with something else. That's exactly what we're going to be doing here, taking something out and replacing it with something else. Basically, the steps that we're going to need for substitution are right over here. We got step 1, step 2, step 3, step 4. Those are the 4 things we need to do for substitution. All right, so let's see here. Our first system they gave us is x minus y equals negative 11, and 7x plus 4y equals negative 22. I want to know what is the solution to that system. So the first thing they want us to do is solve for a variable in one of the equations. They just said solve for a variable. They didn't say solve for x. They didn't say solve for y. It's our choice. So what I think I'm going to do is I'm going to take this first equation here, and I'm going to solve it for x. It's my choice. Now the reason I chose to solve for x is because in order to do that, all I have to do is move my y over. So now I have x is equal to negative 11 plus y. All I did was move the y over. So that takes care of my first step here. Solve for a variable in one of the equations. Step 2 says, in the other equation, replace this variable with its equivalent expression. So now I'm going to move on to step 2 here. It says here, use the other equation. So I'm going to use the 7x plus 4y equals negative 22. What I'm going to do is replace the x with its equivalent expression, which in our case is negative 11 plus y. Everything else is going to stay the same in the equation. This is why we call it substitution. We're taking something out and replacing it with something else. Now notice here I've got an equation, and the only variable in that equation is y. So what we're going to do is we're going to solve for that y. 7 times negative 11 is going to give us a negative 77. 7 times y is going to give us a 7y. And of course we still have 4y equals a negative 22. By the way, notice we're doing step number 3 right now. We're solving for the variable. We're working on step number 3. Notice we can combine those y's together. If I put a 7y plus 4y together, that gives me how many y's? 11 y's. So I got a negative 7, negative 77, plus 11y equals negative 22. I'm still solving for y, so I'm going to add 77 over here. Negative 22 plus 77, what is that? 55. 55. And the last thing I'm going to do is divide by 11. So 55 divided by 11 is a 5. So the x value is 5. Bad news is we're only halfway done. All we've found so far is the x value. We still need to figure out what the y value is in this system here. So how are we going to do that? Well, if you look at step number 4 here, 4 says substitute the answer, which is 5 in our case. Substitute the answer into another equation to find the value of the other variable. So what are they talking about here? Step number 4. We're going to take this 5 and we're going to plug it in for one of these x's up here. We can either use the first equation or we can use the second, whatever looks easier to work. I'm going to use the first equation. I'm going to take out x and replace it with 5.
Isn't it y?
Oh, yeah, you're right. It is y. That should be y equals y, not x. We can still use the same equation, all right? We can still use x minus y equals negative 11. The only difference is now we're plugging in the 5 for the y, not the x. Very good. Remember, I told you I do that on purpose sometimes to make sure you're paying attention. Good job. One person was awake in car. Good job. Y'all didn't want to say nothing, right? All right, so let's solve for the x. We know what y is. It's 5. Let's solve for the x. Let's add 5. And a negative 11 plus 5, negative 11 plus 5 would give us a negative 6. So now we have both the x value and the y value. However, usually when we write the answer, we write the answers in ordered pair. So what would the ordered pair be? Negative 6, positive 5. There's our solution. I know what you're thinking. You're thinking, well, couldn't I just graph that and find the intersection point and it would have given me negative 6, 5? Absolutely. Give us the same exact answer. So why are we doing this? Well, how many of us have one of these calculators that can actually graph? Some of us do, some of us don't. So this is why we got to make sure we have other methods, backup plan. All right, so this is called substitution. There is quite a bit of work involved here, guys. It's probably one of my least favorite, substitution. There are some other methods that we'll be looking at, but we are required to show you substitution. All right, let's keep going here. Now, on this next part, they give us 4 different systems. Now, we're not going to necessarily solve these right now. All they want us to do is look at those systems and identify, right here it says, identify which variable would be the easiest to solve for. So right now what we're going to do is identify which one would be the easiest to solve, which would be the easiest first step. So if we look at the first equation, or the first system, which variable would be the easiest to get by itself? Y. On which one? The first equation or the second equation? The first equation. Now we'll probably get the y by itself. So circle that y. It's probably the one that I did by itself. If you look at the second system, which variable would you get by itself? So which one? For me, I'd probably choose the x right here. Would it make it wrong if you chose to get y by itself? No, it wouldn't make it wrong. Might make it a little bit harder for you, but it's not going to make it wrong. Look at the third equation over there. Which one would you get by itself? Probably the y right here. Now, I don't know if you've noticed it, but all these ones that I'm choosing, do you notice something about the y values and x values that I'm choosing? What do they have in front of them? The 1. All right, so try to choose something that doesn't have a number in front of it or 1. Okay, it's going to make it a little bit easier. Now, unfortunately, sometimes that's not the case. If you look at the last system, there is no variable that doesn't have a number in front of it. So we would still have to choose one. It really wouldn't make a difference for me. I would probably choose this one right here. If you choose something different, it wouldn't necessarily make it wrong. It might make it a little hard, just not wrong. All right, so all we did was identify what's easier to solve. So now let's take it a step further. It says here, number 1, now solve the system, showing your work. So this was the first example they gave us. We said we were going to get the first equation and get y by itself. So right now I'm doing step number 1. I want y by itself. So that's pretty easy. All I'm going to do is move the 4x over to the other side by subtracting it. So that's going to give me y equals negative 4x plus 3. I just did step 1. I got a variable by itself. Step 2. Use the other equation, which in our case is going to be the 7x plus 2y equals 4. Use the other equation, but replace the variable with its equivalent expression. So we're going to replace y with a negative 4x plus 3. Everything else is going to remain the same. And from here, we're going to solve for the x. So 2 times the negative 4x is the negative 8x. 2 times 3 is going to give us a 6. So here's what I've got so far. Now I'm going to combine the like terms. 7x minus 8x is going to give me a negative 1x. By the way, notice all this work that we're doing right now, that is step number 3. The work that we're doing right now is step number 3. Let's subtract 6. 4 minus 6, what's 4 minus 6? Negative 2. We're almost there. Divide by negative 1. And a negative 2 divided by negative 1 makes it a positive 2. So our x value is positive 2. We're almost there. We still need to figure out what y is. So we're going to take this 2 that we just found, and we're going to come over here and plug it in for one of these x's. The choice is yours. You can use the first equation or the second. I'm going to go ahead and use the first. There it is with the 3 plugged in for the x in the first equation. Solve for the y. 4 times 2, of course, is 8. Subtract 8. And 3 minus 8 would give me a negative 5. So my y value here is negative 5. However, don't leave your answer like that. I want you to write these answers as ordered pairs. So what's the ordered pair going to be? 2, negative 5 or negative 5, 2? 2, negative 5. X value has to come first. So there's our solution to the system. Again, guys, had we graphed this, we would have seen that the 2 lines intersect, and they intersect at the point 2, negative 5. This is just another method to come up with the same answer. There is quite a bit of work involved. Okay, let's try the next one here, number 2. Number 2. First thing I need to do again is to get a variable by itself. It can be any variable. We said we were going to take the second equation, and we're going to get the x by itself, because there is no number in front of the x. So what I'm going to do is move that 20 over here, which is now going to give me 7y plus 20 equals x. There is step number 1. I've got a variable by itself. For step number 2, I have to use the other equation. I've already used the second one, so now I've got to use the first one. So now I'm going to use 9. Remember, we're going to replace x with the equivalent expression, which in our case is going to be the 7y plus 20. You can go ahead and write down the rest. Plus 11y equals 32. And now we only have one variable, and we're going to solve for that one variable. 9 times 7y. What is 9 times 7y? 63y. 9 times 20. 9 times 20 is 100 and what? 80. Still got the 11y equals 32. Combine those y values. You got 63 and 11. 63 and 11 would make 74. 74y plus 180 equals 32. Subtract 180 from both sides. So 32 minus 180, help me out with the calculators there. 32 minus 180 is negative 148. Negative 148. We're almost there. Now we're going to divide by 74. So a negative 148 divided by 74 turns out to be what? Negative 2. All right. So the y value here is negative 2. We're halfway there. Last thing we need to do is find out what the x is. So we're going to take that negative 2, and we're going to plug it in for one of these y's. The choices are, we can put it anywhere we want, as long as it goes in for the y. I think I'll use the second equation. Doesn't make it wrong if you use the first. Okay, let's see what we get here. 7 times 2, or 7 times negative 2 would be a negative 14. I want to solve for x, so now I'm going to add 20. So a negative 14 plus 20, negative 14 plus 20 would give us a 6. So x equals 6. But again, just make sure you write it as an ordered pair. And in this case, that ordered pair would be 6, negative 2. And there it is. So again, this is just a different method to solve a system. We can graph it. We can also use substitution. All right, I want you to try one on your own for me. I want you to try number 3. All right, get number 3 all by yourself. I do want to caution you, make sure you take into account that is a negative sign in front of the y. Be very careful. That is a negative in front of the y. All right, let's see how you did on the first step. Just the first step is what we're looking at right now. Jose, what did you use, the first equation or the second equation? Second equation. And what variable did you get by itself? Okay, use the first equation, and what variable did you get by itself? The x or the y? All right, so let's check it out and make sure we did that correctly here. So you took the first equation, got y by itself. So the first thing you did was what? Move the 8x to the other side, which gives us a 90 minus 8x, or negative 8x plus 9. It's the same thing, right? Then what? Did you leave it like that, or did you do something else? Divided by negative 1, which gave us a negative 90 plus 8x. Or if you have it in reverse, 8x minus 90, again, it's the same thing. All right, so there was the first step. I'm going to write this second step over here. We're going to need some room. Since we've used the first equation, now we got to come over and use the second equation. So now we're going to use negative 3x plus 7. Of course, we're going to take out y and replace it with negative 90 plus 8x equals 112. Now I need to solve for x. All right? So Annika, help me out here. First thing we need to do is distribute it properly. So what did you get when you multiplied 7 times a negative 9? Negative 630. What about 7 times 8x? 7 times 56x. And of course, it still equals 112. Gotta have that x on that. Now I got to combine the like terms, so a negative 3x plus 56x was what, Adam? 53x minus the 630 equals 112. Then what'd you do? 630. We're going to add the 630 to the 112. And what do you get when you add that 630 to the 112? 742. We're almost there. Divide by 53. And what do you get when you divide it by 53? X equals 14. Okay? So that is correct for the x. Of course, we still need to figure out what y is. That's going to be our final step here. So we're going to take that 14 and we're going to plug it in for one of these x's over here. All right, so Andy, where did you plug it in? First equation or the second equation? First one. Okay, we'll use the first one. So we're going to replace x with a 14. And we're going to solve for y. So what do you get when you multiply 8 times 14 in? 112. Then what did you do? Subtract 112, and what do you get when you subtract the 112 from the 90? Negative 22. And finally, you do what? Divide by negative 1, which gives us the final answer of positive 22. But Marissa, you didn't leave your answer like that, right? How'd you write it?
14, 22.
Ordered pair, 14, 22. So make sure you write it as ordered pair. X value being 14, Y value being 22. All right, so this takes care of substitution. We're going to go ahead and skip over number 4. Don't worry about this one. We're going to move on here to this right here. Now, it says that sometimes solving systems with substitution can yield some strange results. Strange results. Now, what do they mean when they say strange results? Well, let's take a look here. We're going to do 2 more examples. Here's number 5. We're going to use the same method, substitution. The first thing I'm going to do is get y by itself. So I'm going to take that 5x plus y equals 2, and I'm going to get y by itself, which means I'm going to move that 5x over by subtracting. So there's the first step. I'm doing exactly everything the same way I did earlier. Now I'm going to use substitution. I'm going to take out the y on the other equation, and I'm going to replace it with a negative 5x. Here's what I've got. Let's use some distributive property. 2 times negative 5x is a negative 10x. 2 times 2 is going to give me a 4. And of course, it still equals 9. Now I need to combine the like terms. I've got 10x minus 10x. What is 10x minus 10x? 0x. There are no more x's. They're all gone. So I've got 4 equals 9. Now remember, it says something strange was going to happen. What's so strange about that? What's missing? There's no more variables. That's one thing. It's no more variables in the equation. What else do you notice about what this says here? It says that 4 is equal to 9. Is $4 the same thing as $9? No, this is not true. 4 is not equal to 9. That is absolutely false. And anytime we have a false statement like that, we say that there is no solution. No solution. In other words, if we had graphed these 2 lines, what would have happened if we would have graphed those 2 lines? Parallel. They would have ended up being parallel, which is why we're having no solution. So this is what a no solution is going to look like working it algebraically. You're not going to have a variable, and the 2 numbers are going to be different. They're not going to be equal to each other. All right, let's take a look at number 6. Number 6. Something strange is going to happen on number 6 as well. First thing I need to do is get a variable by itself. Which variable are we going to get? An x or a y? What do you want to do? X or y? Y on which one? The first one or the second one? First one. Okay, let's take the first equation. And you said, which one are we going to get by itself? The y? Okay, we'll get y by itself. We'll move the 3x over first. We'll add it. So now we've got 3x minus 24. Anybody see what's going to happen? What's going to happen when I do division of 9? You're going to get a fraction. You guys like working with fractions? No, I don't either. Is there a way we can avoid the fraction? Anybody see anything we can do to avoid that fraction? How about we do this instead? Let's go ahead and use that equation. But rather than getting y by itself, what if we get the x by itself? Let's see if that's going to make any difference here. Let's move the 9y over. So now we got negative 9y minus 24. Still going to have to divide. What are we going to divide by? A negative 3. If I divide by negative 3, am I going to get any fractions? No, not this time. So this is why I say something. You got to really look at what you have to determine what variable you're going to get by itself. Negative 9 divided by negative 3 would make that a positive 3y. A negative 24 divided by negative 3 would be a positive what? 8. So that looks a lot better. I don't like fractions any more than you guys, so that's one way we can avoid the fractions. Okay, there's the first step. Now we need to take that and plug it into the other equation. So now we're going to use the 2x minus 6y equals 16. Of course, we're going to replace the x with a 3y plus 8. And let's see what happens this time. 2 times 3y. 2 times 3y is 6y. 2 times 8. 2 times 8 is 16. So here's where I'm at so far. Look what happens when we combine the like terms. 6y minus 6y. 6y minus 6y is 0. No more y's. All we have is 16 on the left, 16 on the right. So again, something strange happened. Just like number 5, there is no more variable. But look at the statement. It says 16 is equal to 16. Is that true? Yes. And because that is true, we don't say there's no solution this time. What do we say instead? There's an infinite number of solutions. This is one of those examples of using the coinciding lines. This is an example of when those two lines are on top of each other. Now, again, we don't see these quite a bit, but every now and then you'll come across one that has a no solution and an infinite number of solutions. And this is what it's going to look like when we solve it algebraically. All right, so this takes care of substitution method. Substitution method. So let's see if we can summarize real quick what we just found out. It says when solving systems algebraically, and you come up with a statement that is what? Not true. When you end up with an equation that is not true, and they give you an example over here, 4 is not equal to 9. That is not true. This system has no solutions. No solutions. Or it is, what do we say when we have no solution? We call that inconsistent. Inconsistent. Or graphically, these equations, the equation lines would be parallel. Anytime we have no solution, we know the lines end up being parallel. Again, this is only if the equation is not true. The other example we had was, what if it is true? Well, if you end up with an equation that is, what goes in the blank here, is always true, such as this case right here, negative 24 equals negative 24. Then the system has an infinite number of solutions. or it is, what do we call it when it's infinite number of solutions? We call it consistent. Consistent. Or graphically, the equations lines would be what? Coincide. Coincide. Again, that takes us through substitution method. You guys probably have heard of substitution method before in your Algebra 1 class. These 4 problems right here, we're not going to mess with those. That's going to be your assignment, your homework, those 4 problems using the substitution method. So we're not going to touch those. That's your homework. So you might want to make yourself a little note there. We'll check those on Monday. We're going to move on to something called elimination method. This is another method to come up with solutions to our systems. Elimination. Now, this part right here, they make it a little more complicated than it really needs to be. So I'm going to skip this particular section right here, guys, and I'm going to move on to the next part. We're going to use elimination. Now, elimination. Kiki, what does the word elimination mean? To get rid of. Elimination means we're going to get rid of something. So, if you look at number 11 here. Number 11. We're going to use elimination method. Here's how it works. We're going to take those 2 equations, and I'm going to add them. Tell you what, let me write it over here so we can see a little better. Let's take the 2 equations. And what I'm going to do is I'm going to add those 2 equations together. I'm going to add them together. In other words, I'm going to take this A and add it together with this A. So A plus another A is going to give you a 2A. Now I'm going to add the B's. I've got a B plus a negative B. B plus a negative B is a 0. There are no more B's. What just happened to the B's? They just got eliminated. That's why we called it elimination. We're trying to get rid of something. And we just got rid of the B's. But we still got to add up these 2 numbers over here. We got to add up the 19 and the 7. 19 plus 7 is going to give us a 20 what? 26. So now what I have is the equation 2A is equal to 26. If I want to solve for A, of course, I'm going to need to divide by 2. So 26 divided by 2 is going to give us a 13. So I'm halfway there. I already know what A is. I know that A is 13. But if I want to find out what B is, how do I find out what B is? Plug it in. Take the 13, plug it in for one of these B's. It's your choice. I think I'm going to use the first equation. I'm going to replace the B with a 13. And I'm going to solve for A, which means I'm going to need to subtract. So 19 minus 13 is what? Ah, very good. Man, you guys are awake today. Alright, so we're going to plug it in for A. And that's going to make a big difference, right? Subtract 13. 19 minus 13 is 6. So it turns out to be the same number, but it is the B value, not the A value. But we're not going to write it like that. We need an ordered pair. Now, usually when we have ordered pairs, we think of it in terms of X and Y. This time we have an A and a B. So what number is going to go first, the 13 or the 6? 13, 6 goes last. It's alphabetical order. So 13, 6 is the ordered pair. That is our solution. So to come up with the solution, if you take a look here, this is how much work we had to do using the elimination method. If you go back to that substitution method that we were using earlier, let's go way back over here. Look at all that work I had to do to get this answer right here. So if you got your choice, and you can do it either way, substitution or elimination method, which one is probably going to be the shorter method? Elimination. All right. So usually, if I have to do it algebraically, I prefer elimination method because it is a little bit shorter. Of course, sometimes substitution. There are some benefits of substitution as well. All right, let's try another one here. Let's try number 12. Here's the system we're working with. Just like we did with 11, we're going to add the two equations together. 5x plus a negative 5x is a 0. There are no more x's. 3y plus 2y would be a 5y. And 31 plus 4 is 35. Divide by 5. And 35 divided by 5 is 7. So the y value here is 7. Now we've got to figure out what x is. So we're going to take that 7 and we're going to plug it in. You can use it for the first equation or the second. I'm going to use it in the first. Replace the y with a 7. So 3 times 7 is a 21. I'm going to subtract 21 from the 31. What's 31 minus 21? 10. Divide by 5. And 10 divided by 5 is 2. But of course, we're going to write that as an ordered pair, and that ordered pair would be 2, 7. Write it as an ordered pair. All right, you guys do number 13 for me. Try number 13, see what you get. Okay, looks like you guys got it. So if we add them together, 9x plus 1x is going to give us a 10x. Negative 2y plus 2y is 0. 17 plus a negative 7 is a 10. Divide by 10, so the value of x is 1. So we know what x is, we know it's 1. So we're going to take that 1 and we're going to plug it in for one of those x's. All right, so where we're going to stick it? We're going to the first equation and the second equation. Okay, we'll put it in the first one. So we got 9 times 1 minus 2y equals 17. Of course, 9 times 1 is 9. What did you do after that, Mercy? Subtract it, so what was 17 minus 9? 8. Then what? Divided by negative 2. So 8 divided by negative 2 was a negative 4. So the final answer was what ordered pair? 1, negative 4. So make sure you write your answer as an ordered pair. All right, guys, we're going to go ahead and stop right there. We'll finish up the rest on Monday. What I need you guys to do for me, we've got a couple of minutes here, is now you can go back and finish up those 4 problems using the substitution method. That way you don't have to worry about any homework over the week.